All right, it's been a long time since I did a stream, and every time I make one, it's like I forget how to do it. So every time is a new process. Uh, Let me see if this is working. And my poor MacBook. I'm trying to stream in 4K, but it seems like it's too difficult for it. So maybe the stream is lagging. We'll see. And also, I don't make any like plans to stream, which is bad as well. Like I should have some type of mention that, hey, I'm gonna stream now. Kind of just turn on the stream and here we go. So, well, let me see if this is working. So there are people watching. I don't know how to bring out the chat on this. So let's see here. Okay, cool. And then maybe we can do pop out. All right. So let me know if this is working. If anybody lets me know. I guess I could also watch my own stream and that would work. Um, yeah, so it seems to be working. Cool. And yeah, so I thought in this stream we would play around with like visual language models. There have been some new ones that's been released, and so specifically this CogVLM. I saw this from I don't know how to pronounce it actually, but Peter from LinkedIn, he posted it. Like a comparison of different language models. And so this is one that was released not too long ago. I guess like I would say like this month at least. And so from the performance chart and just people talking about it, it's had really good performance, especially compared to Lava. So it's, if you look at Lava here, I don't know exactly these benchmarks here, but as you can see, on this, right? Lava is let me just check if I can get. Oh man, I had the chat and now it's gone. Okay. So why is it not? It should be showing like I think some people have been writing, I guess. Mm. Yeah, I'm not really sure. So maybe it's because I have some ad block or something. Okay, here it works. So, um, so let's take this. All right, cool. I'll just have it to the side so I can see it at least. Yeah, so back to what I was talking about. Um, I want to play around with the CogVLM and just let's see like how good it is, and try it out on a few images, and hopefully we can get it to work as well. So what we need actually to be able to run this, it's kind of unfortunate like how in compute heavy these VLMs are, or LLMs in general, right? To be able to run Llama 2 70 billion, I've never even been able to run it locally because you need such a powerful GPU with some like you need really a lot of VRAM and a lot of RAM. So I actually haven't been able to run that. I think the biggest one is 13 billion, or that I've been able to run. So for this, I was thinking, probably it says here that we could run it on two 3090s. So we could perhaps, I have two 3090s, so we could perhaps run this locally. But I think I'm just gonna rent an A100, and then it'll be easier for us to play around with it. So yeah, basically, if we just go through this, I have not gone through this like in detail, so this is also new to me. But basically, it has 17 billion parameters. It has 10 billion vision parameters and 7 billion language. And I guess it's like similar to Lava and so on. I'm curious what they did differently, but they surpass a lot of the previous performance, as we can see on all of these benchmarks. Not too familiar with all of them. Um, yeah, I think the best way to kind of evaluate these performance too is just try it out and then get a feel for it as well. So here you have like some image, that's kind of thing. Please describe this image, and then it describes it. Mini GPT-4, as many people know as well, maybe, and then Lava 1.5. Lava 1.5 is, in my experience, very bad. But one thing that I want to try as well is baklava. So this is what Peter mentioned as well on LinkedIn, which I thought was hilarious. Unfortunately, it doesn't seem too good. I was kind of hoping this would be the best one. Man, is this chat working or no? Uh, and poor laptop, it's kind of overheating. I should not be streaming in 4K on this laptop. Overheating. All right, I'll just assume that it is working. Hopefully, it is. Maybe I should restart the stream though, so that I have 1080 instead. Maybe I'll do that for the next stream. We'll see if this one survives. Okay, so anyways, let me first on the side here rent a A100 so that we can use a VM. Yeah. Okay. So I'm trying to deploy the VM, and then we'll try to set it up quickly. All right. So method CogVLM compromises four fundamental components: VIT, MLP adapter, a pre-trained language model GPT, and a visual expert module. So I guess maybe that's like the new part of it. So I'm actually a bit unfamiliar with how this works exactly because I haven't read. I mean, from my understanding, it's like you basically just hook up two Lego blocks with the um, like a VIT and then some language model, essentially, kind of like image captioning, but with bigger and better models. But let's see, like, curious how this looks. All right, so um, so I guess like they use a VIT, they patch the images, they run into a VIT, they have some MLP adapter, image feature sequence, and then they concatenate it somehow with text feature sequence, and they have some paired text. So I guess like this is the input, right? You input an image and you input text. But then B is the visual expert built on the language model. Okay. Maybe we should open up the lava paper as well, because I think this one is a little bit easier maybe to understand. Let's see. So that we can know like what is the actual improvement from the two. Has anybody played around with these, by the way? I mean, Lava and CogVLM. I guess CogVLM people haven't played around with too much, maybe because it's kind of new. But Lava, I assume, kind of most people have played around with. So they have an image. I would really like to like actually build one of these because it's like when you read it, it just looks very complicated. But then when you actually implement it, you realize that it's maybe not that difficult. So like you have an image, you run it through a vision encoder, you have some projection, some MLP, right? And then you get some intermediate um, embeddings, and then you have some instruction as well that you input, and then you run it through the language model, basically. So you input this to the language model, and then so basically, I guess like all you do is that you run it through separately, like two Lego blocks, and then you concatenate them. But so I'm wonder what the difference is for the CogVLM part. All right, so I've also, oh man, my computer is lagging. Hopefully the stream is not. Um, are you gonna post videos on recommender systems? Yeah, I've actually made, at least like created the code for several videos. I've recorded one more that I'm gonna upload. But I mean, the first ones are gonna be pretty basic, and then I'll um, and then I'll uh, create more. I think it's gonna be like an ongoing effort to make that series. All right, cool. Let me clone this. So I created this yesterday, by the way, because I'm gonna start using virtual machines more. I think I'm gonna start renting more because these models are getting out of hand. I don't know exactly if so either I spend the money to buy like a solid rig that you have and you can use it all the time. But if you're gonna be playing around with these models intermediately, then maybe it might be worth it to rent. So that's what I'm doing now, at least. until I figure out what the best plan is. So I was playing around with this yesterday of like creating a coding environment, because I think when you work a lot in the VM, I actually like to have a lot of stuff um, like through NeoVim, because it's just easier. Like you just SSH and then that's it. There's no complex stuff. I mean, you can do that in Visual Studio Code, right? But it's kind of easier, I think. There's just some errors as well when you use Visual Studio and you SSH. Then um, if you like turn down the laptop or something, you lose your connection. I don't like that. So this I can use tmux, I can SSH, I can use nohup and just run the script. I'll just SSH back, tmux, and back. So let's see, we'll run this. This is like, I'll show you. I guess now I can't run. Here I created like install all the stuff that I need basically, and then we'll see if this works. First, like it's gonna need to update and stuff. Okay. So we'll just let it run a little bit. I'm doing update and upgrade as well. I guess it takes some time. So I don't feel like this is very descriptive. Like I would want to have a better figure here of what they're doing. Let's just read the abstract first. Instruction tuning large language models using machine generated instruction following data has improved zero-shot capabilities on new tasks, but the idea is less explored in the multimodal field. In this paper, we present the first attempt to use language-only GPT-4. Okay, to generate multimodal language image instruction following data. We instruction tuning on such generated data, we introduce Lava, large language and vision assistant, and end-to-end trained that connects a vision encoder and LLM for general purpose visual and language understanding. Our early experiments show that Lava demonstrates input. Okay. I mean, basically, I think I guess it's on the data as well. I'm not sure how they actually generated the data. So they specifically, in order to decode an image into its visual to prompt, we use symbolic representations. Yeah, okay. I mean, like, sure. So I think the data set is way inferior as well here because they're using some hacky way of generating the data. So maybe let's see if this explains it a little bit better of what they're actually doing. CogVLM, a powerful open source visual language foundation model, different from popular shallow alignment method which maps image features into the input space. CogVLM bridges the gap between the frozen pre-trained language model and image encoder by a trainable visual expert module in the attention and FFN layers. As a result, CogVLM enables deep fusion of vision language features without sacrificing any performance on NLP tasks. CogVLM 17 billion achieves state-of-the-art performance on 10 classic. All right, cool. So, okay, so it can do detailed, descriptive, and visual question answering. Where might this photo have been taken? This photo was taken in Hawaii, specifically. Wow, okay, that's actually. So this is like like how I never trust these papers in like the performance. Obviously, like I would want to let's try this ourselves when we've set this up. And let's see if this works as well. As I said, like I'm usually using my local, so I tried to do this script yesterday of of installing everything I need on a VM so that I can set it up quickly. But I mean, like, this is insanely impressive if it can do this. I don't know if even, I guess GPT-4 can do this in many cases as well. Complex counting. How many houses are in this cartoon? Oh man, 4. Okay. Okay, that's actually quite impressive, I guess. Visual math problem solving. How to solve it. 2 plus 1 equals 21. Let's see. I joked on X about fighting Zuck. This seems, I mean, Elon is also pretty serious about fighting Zuckerberg. He was like, it was like going to his house or something, he said on the Joe Rogan podcast, but Zuckerberg wasn't there, wanting to fight him. Uh, anyways, so OCR as well is, Lava is horrible, I think, on that actually. So yeah, OCR free visual question answering. We'll try these out, right? And we'll see for ourselves if it is actually this good. Programming with visual input, grounding with caption. Oh man. Grounding, visual question answering. What's grounding? Grounding. What colors are the clothes of the girl whose hand are holding the flower? I'm not sure what grounding means. So, okay, it's finding the flowers. Okay. Okay, so those are some really impressive examples, right? I mean, if we look at the lava paper. All right, well, I mean, it's also, so this is the thing, right? I know lava is not good, but you can find good examples. So, yeah. All right, is it done now? All right, cool. Oh, okay. Oh, LSP0. LSP0 not found in require. Okay. Cool. All right. It actually is working now. Cool. So, what are we wanting to do? Do we have NVIDIA? No. Okay, so let's see. What do we need to install? I mean, we need to install like Conda, NVIDIA driver, and I haven't done this too much, to be honest with you. So maybe we can try and do this. And by the way, this is something that actually I think is pretty good. This is a big AGI. Have you guys played around with this? Instead of using, I mean, like the chat GPT, where, I mean, you can do, like you can use the API yourself instead. I guess there's no, like, you can use as many chats as you want, but you pay for it, obviously. But then you can do more customization with the temperature and all of these things. From where do you rent workstations? I actually, I mean, I actually don't want to specify exactly where. I'm just trying these things out at the moment. So, and I'm not affiliated with any of them, but I think there's one some v something dot AI, and then that I've read about, and then the one that I'm using now is Fluid Stack that I'm trying out. But yeah, let me, if I'm gonna do this, I'll play around and I'll make a video maybe on how which one I think is best and so on, and we can check that out. But that's what I'm using now. All right, so let's see. Let's see. So I'm trying to install NVIDIA drivers on Ubuntu. I believe there is a driver 570, but when I search, I only find up to 535. Is there a way to get newer drivers? Okay. Maybe we can do that. Okay, maybe that is the newest then. I'm not sure. I really remember that there was one a 570, but I guess I was wrong. Let's just, I guess, take 535 then. No, so this is not correct. This is like utils. So this is not correct, right? Like we should have the actual driver here. So let's see, maybe this one will find it. Yes, here we go. So the latest one is 545 open, 535. Let's see. So this is on an A100. I think the 535 is maybe the one we should go for, but let me check if it has an ID as well. Okay, we could do that as well. All right. It's trained from Vicuna 7 billion, so that's like the LLM that it starts with, and then does anyone know what this rope means? Position IDs for rope. I mean, this makes sense, right? We put some sequence, we concatenate them, and then we get this. I'm not sure why we have zeros and then we get these position IDs. I don't know what this rope stands for. Huh, okay. But they basically, I mean, here you have like the block, right? The transformer block, and then you put it goes out here, the image features. Man, it might almost be easier to understand this in code, to be honest. Like what's happening here exactly. I mean, it's like putting them in some smart way, I guess, with the keys. It's like, is it concatenating the different query keys and values with the image feature and the text, or So architecture, it has 4 fundamental components: a VIT, MLP adapter, pre-trained GPT, visual expert module. Okay, so those are different. So you have the VIT, you have the MLP adapter, you have actual GPT, which is the Vicuna 7B, and then you have a visual expert module, which is this. And I think this is what's new in their actual, like, their contribution, I guess, that makes it perform much better. But also I think the data, I'm curious what data they used. So let's see here. VIT, we utilize pre-trained EVA to clip E. Okay. Does anyone know what this is as well? Improved techniques for clip at scale. There's so many things, man. I'm so there's so many things to learn now. Like these are all new to me as well. All right. EVA clip. Okay, so basically, I mean, like clip. So like they have, like, just let's just simplify it. It's some improved clip. That's it. So this we can, I mean, we could probably look at this in a separate one as well. What they actually did to improve the training. But so they use that. The final VIT is removed. Okay, MLP adapter is a 2-layer multilinear perceptron to map the output of VIT into the same space as the text feature from the word embedding. Okay, so I guess that's what they do. The MLP adapter is on top of the VIT encoder that they add here, maybe. So they have some linear here, perhaps, so that they can then put it together with the concatenate them or something. Pre-trained large language model, Vicuna 7B. A causal mask is applied to all detention operations, including detention between image features. Okay. We add a visual expert module to each layer to enable deep visual language feature alignment. All right, kind of jumping between here, guys, trying to set this up at the same time as we're reading it. Oh no. That's not good. Do we need to reboot? Do you need to reboot? Okay. Cool. Let's do that then. Yeah, okay, where were we? So specifically, visual initially consists of a query key value matrix and an MLP in each layer. The shape of the QKV matrix and MLP are identical to those in the pre-trained language model and initialize from them. Okay. The motivation is that each attention head in the language model captures a certain semantic information, while a trainable visual expert can transform the image features to align with the different, therefore enabling deep fusion. Okay. So let's see, what is this? So we have the attention, right? But then they have, what's this? Lower triangular mask. Okay, so they mask this. Okay, this is getting over my head. What's actually happening here? Okay, we have VI, VT. So these are the actual, like, QKV matrices of the visual expert and the original language model. And X is the, what is X? Text hidden states. X is for split. Okay, you split it. I mean, basically, okay, so basically, like they do it. They basically do the same thing on the image and the text hidden state. So these are the um, let's see, the W or the, yeah, okay. So they have like the uh, Q key V matrices of the image and the text, and then they concatenate them and they basically apply it on top, I guess. Okay, so I mean, we would have to run this into like, we would need to code this, right, to actually like understand it. But as an basic understanding, I think we maybe get it. So they basically do some type of attention on the queries, keys, and values of the visual and the image, and they seem to do them a little bit separately, but then they concatenate them to for the new query and the new key and the new value. My only issue here is that isn't the size gonna be stacking if we do this? So if here they are concatenating, aren't they basically increasing in size every time? So then we would increase size. By the way, is there anyone in chat? I don't know if this one like it breaks or not. So yeah, all right. I'll there hasn't been anyone saying anything for a while, so I'm just wanting to check. All right. So I mean, like here, basically, what I'm thinking is, if we do that with concatenating them, then wouldn't we be just like increasing? Maybe you put down the actual size again after you do that. But all right, so that's what they do basically. So is the improvement, if there is an improvement, let's try it as well. And then NVIDIA Smile, please. Yes, nice. Okay, cool. So what else? We need to, actually, let's remove Miniconda here because I want to install it from scratch. So what are the commands to install Miniconda on my VM? Come on, let's go. This is so annoying, by the way. Like every time I install Miniconda, I have to do this. And then if you bypass the end, oh, okay, it actually didn't. So usually when I bypassed it, it actually like removed, so I have to do it again. You can undo. Yes. Source. Okay. Cool. Let's see now. So we have Conda. Yes. Cool. Conda create cog, I guess. Conda install pip. And let's go to cog. Let's clone this. Tell us how much the GPU costs you. I think it's pretty. It's like $2 an hour or something, I think. What did I just do? Okay, I cloned it. Let's go to that one and let's install all the requirements here. Okay, the data. The image text pairs for pre-training are publicly available. So they have this data set, which is, I guess, actually, I should like check these data sets and play around with them a little bit at some point in time. But they have these two, and then after removing the broken URLs, images with noisy captions, they keep 1.5 billion images. Then they craft a visual grounding data set. I don't know what they mean by grounding data set. Okay, so each noun in the image caption is associated with the bounding boxes to indicate the positions. The construction process follows which extracts nouns via spaCy and predicts the bounding boxes using glib v2. Okay. Okay, this is cool. So that's similar to what Lava did, I guess. So that they have the position, right? Or was it Lava that did that? Or am I mistaken? Yeah, so that's, I guess, what they did as well with the grounding part. And then they fine tune it, CogVLM chat. Okay, so they have CogVLM chat as well. Free form instructions of any topics. So this is like the final type of fine tuning on top, I guess, where, you know, this is the instruction fine tuning part. And then these are the actual like table for performance. I mean, like, so we have a bunch of different ones here. Don't know exactly, but it is outperforming one that has 55 billion on many of them, which is impressive. Mini GPT-4, Lava, and then this one is good as well, CogVLM. All right, so and now we need to run this thing. And we also want to run, let's see, the web demo would be cool. Maybe I need to do some port forwarding. They should have included which versions and stuff for these. All right. Also want to know like what actual image sizes, because I saw 240 and 490. Do they mention that somewhere? Resolution. Okay. Let me also put this on LinkedIn. Maybe that will increase the amount of people joining the stream as well. Mm. Let's see if it gets the image as well. Nice. All right. AI, ML, deep learning. Does anyone know which tags to use for these, by the way? I'm always confused. I guess AI, ML, deep learning, machine learning, field, the AGI. Cool. All right. That's fun. So yeah, like they changed the resolution. Um, I mean, this is still like pretty small resolution. Did they also use similar resolution? I guess it depends on the VIT, right? So let's see. Uh, you are a machine learning researcher. Follow the instructions carefully. Um, does a VIT vision transformer usually use as input? $384, $384. There should be some with 490 or something. Otherwise, all right, let's see if this works now. It's unzipping, and so I would really like to use the web demo. That would be the ideal one. And then they have two different ones. So they have the chat one, which is the one we read about, right? And then they have this grounding generalist. The grounding one uses it actually gets like in position information. So it uses this some other kind of thing, this glip v2. I don't know. You tell me if you're familiar with glip v2, but I guess like it predicts the bounding boxes, and then that's inputted as well. So then it has the position information. And then we have as well, we have I don't know what the difference is here. So this is a CLI demo. Then we have a base. I don't know why you would want to use the base. So what's like the pros and cons? I guess it's like for the evaluation perhaps. Guess you wouldn't want to use it, I think. Okay, that one didn't work. Okay, so which one should we use then? I have no idea. Pip install Gradio 3.33. Okay, and let's try it again. I would really want to use the web demo. That would be the best for me because then we can play around with it much easier. Um, cool. All right, so it is actually working. Now we need to do SSHL this thing, and let's do whatever this was. Exit 94 101 9873. I think this should work, right? So if we, this is annoying as well. It should, I haven't fixed this, so now I actually have to do it by myself. I mean, yes, 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 yes. Give me the rainbow Unicode. 24. Angled, sharp, flat, 2-line. Let's do solid. Left. I don't actually see the difference. Where's the difference? Am I blind? 1. Sparse. Many icons. Concise. No. No. Okay, nice. So cd CogVLM, conda activate cog. What's the command we ran? This. And then now we should be able to do localhost 780. This one. No? Connection refused? Ah. Oh, no, no, no. Okay, so... Oh no, it's lagging. This is why I should have streamed in not 4K because I have 8 gigabytes of RAM on this dumb computer. Oh, goddamn. Oh, it does work. Okay, cool. Hey, this is actually cool. All right, so what did they mention in this actual paper? Like, how good is it? Uh, is anyone here, by the way? It's kind of silent in the chat, so I don't know. And then this is not working too well. Anyways, so they mentioned here like a lot of cool stuff, right? So if it's able to find Hawaii and like the actual island, let's do like Stockholm, which is my city. I mean, it should definitely be able to do this, right? This should be like the easiest thing. Let's do some more. Okay. I mean, we can do the easy one. Let's do this one maybe. Copy link address. Save image. Okay. And then let me drag and drop this. Okay. What do you think, guys? Do you think it will work or no? Let's drag, drop this. Temperature, maybe we should not use that high. I don't know. What prompt did they use here? where might this photo be taken? Photo generate. All right, please work. Please, 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 please. No, no, doesn't look too good. Oh no. Give me this example, please. Click to insert. Man. There we go. Hi, what is this photo? Is it because maybe it's like WebP image or something? And the clear isn't working either, so I don't know. Let us also try the CLI version as well. But this one should work, I think, hopefully. Okay, so I think there's might be something wrong with the connection, probably. So like what I'm trying to do is do port forwarding. Maybe the port forwarding is not, oh, it's lagging again. Next time I'll stream in 1080p. So if it's the problem with that, maybe let's just use the CL. I think it's probably because of that actually, because it wasn't giving anything. It was giving a connection, you know, that there was something wrong with the connection. So okay, so enter image URL. Does this work then? Copy image address. Okay, let's see. User, again, what did they say? Where might this photo be taken? Sten, okay. Okay, that's true. Wow, okay, it's actually good. All right, what city is this? Man, that's good. Hey, that's pretty cool actually. Holy crap. Why is it like so it's like it's like so concise. Can it be like a little bit more verbose or something? How did, oh, let's do just like temperature 0.3 or something. How did they get it this verbose? Because I didn't, it wasn't. Okay. Does anyone have an idea what we want to try to do? Send me a URL of like some image where we can test it so that we actually know if it's good or not. Because I don't know if this so does it have, let's see. Europe. What city do you think it's taken from? Paris. All right, it's wrong. All right. Uh, why is it so like not? Can you be more verbose, please? Fucking hell. Okay. Please respond using multiple sentences. What is shown in the image? Still, it's like so concise. Can you, and also, can you learn how to spell? Like, why is it lower? Come on, like, use proper sentences, goddammit. A woman walking down a cobblestone street. Is it? Was it? Oh, yeah, it was. Okay. Um, what else? Buildings. Damn it. This one is annoying. And then how do you restart it? Do I have to do this? Ah, that's sad. Like I would want to play with it multiple. Um, okay, so maybe let's try some OCR stuff. OCR. Does anyone have some hard OCR stuff that we want to do? Hi, who are you? Oh, press enter for plane. I did. Okay. Um, so it should work, I think. I don't know if there's something that we might have to change maybe. Ubuntu at and then CogVLM. The web demo would be easier, I feel like. We might have to close this. There's no error now, right? Like I'm not seeing connection reviews of any kind. Okay, so can we do this? Click to insert. That's what I'm doing. Okay, exception in data set, something, something. To create a public link, set share. Okay. Should we maybe try install another Gradio? Maybe it's the, maybe it was the version, I don't know. 50.0. It's hard to know when they didn't specify which one to use, right? But that we get an error is probably not good, so maybe that's the issue. Same error. Same here. We also have like connection failed. Okay, so now we get the error we had before. So we should definitely use some lower Gradio. I guess maybe later than 3.33, but earlier than whatever. Let's try 40. All right. And I wonder like how you can also fine tune this, which is really awesome. You need 8 A100s though. But yeah, let's see. Models, CogVLM model. Oh man, it's working, I think. Is it? Oh man, it's working. Oh, this is sweet. This is sweet. Nice. Okay, so what's the difference here? It worked better here, right? If we do the same thing as we did before, let's take the image we had. Let's clear this. Let's input this. Where might this photo have been taken? Fur appears to be, oh, so just it could be a place like Stockholm, Sweden. Okay, and what if we do clear and we do same thing? Where might this photo be taken? And then we just lower the temperature a little bit. Is that when it becomes like non-verbose or something? Okay. And if we generate it again, And if, let's say we put lower, where is this photo taken? Temporary for, hey bro, how are you? I just want to ask remote. Wait, what happened? What, and describe what is going on. Cool. Okay, so I guess like it's a little bit different. If we do temperature 0.1, it didn't seem to work with 0. So I guess you want to put it, if you want to have like really precise, then that's where maybe you want to have it. Let's see, can you explain? Can you explain these parameters in LLM inference? Top P nucleus sampling, top K. So specifically, I'm interested in the top P one. So small set of words whose cumulative probably exceeds the threshold. Okay. Lower P generates text using smaller set, producing more predictable. Higher allows broader. Okay. Top K restricts the sampling pool only to the K most likely next words. Okay, so we're basically like limiting how many of the top K. Oh, is it top K only 10? Okay. That's not a lot. What are the most common values for these? What? Temperature 1? Often a default is used as it reflects the probability predicted by the model without scaling. I don't think that's true, guys. I do not think that's true. But I wonder what happens like if we do 100 there, then we can do describe this image. I guess like yeah, I mean, I don't know if we want to play around with this too much. I probably want to use higher than 10 though. If it's only using like 10 at a time, that would be pretty low. So yeah. I want to try how it is at like OCR stuff. So let's see. I mean, and is it able to do with the grounding stuff? Is it able to? I guess you have to use the different model for that. So this is for fine tuning. This is for using it within transformers. And let's see, where's the grounding one? Grounding. Oh, CogVLM grounding generalist. So the web demo is here. All right. So, I mean, we can use the web demo for the grounding generalist as well. Maybe we want to try that. Let's also try all of the examples here. If we do again, we do this and we do 100. Okay, and if we put 1, it's a little bit strange. I feel like it's a little bit unpredictable at times. Like it sometimes is very mm, please please be very verbose in your response. I mean, this is seriously like it's really good. Let's try it though with some other. I want to try some. Okay, I'm just trying to find an image. So if we do this one, let's see first. If we just, I want to know if it like it knows what the, if it can do OCR on the actual license plate. And let's reduce this to 0.1. What do you see in the image? And additional, so let's do this. What do you see in the image? The image depicts a street scene with several cars. There are buildings and the sky appears to be clear. Could you find the license plate? Well, I feel like I'm doing some like detective work. Can you find the license plate of all the cars in the image? What really? No, it's not correct. MUMH. It's not correct. Okay, so can we do it in another way where it's actually is what is the license plate of the main car in the image? And let's try it around with some different temperatures as well. Yeah, man, it's correct. No, it's not correct. MUEP. So then let's also put ChatGPT like GPT-4 side by side, right? So we can get an actual like. All right, so if I drag it here, and let's do the same thing, right? What is the license plate of the main car in the image? MUEP5D. It's also wrong, so I guess this is not like it's not. This is let's do a simpler one maybe. Oh man, it's lagging again. Come on, man. I was in the US not too long ago and I was really contemplating like should I buy a new laptop because they are cheaper there. There's no like tax on the laptop. But I figured, you know, hey, my laptop is actually pretty good. It's a M1 Pro. The only downside is that it's 13-inch and then it has 8 gigabytes of RAM. And I figured, you know, it works. And apparently it doesn't, right? This sucks. Oh, we're back. Cool. Let's maybe close everything except those three. Okay, so should we try to do another one? So we're specifically, trying to do. Let's do another one. This one maybe. This one is super easy, right? It should be pretty easy. And let's do this. Let's do what? What is the license plate on the car? And let's do this as well. I wonder if like huge difference when you do the CMD262. All right, cool. So it's able to do it on both. The other one failed for both. So I guess like, guys, maybe I need some help here as well. Like, can you help me find what images should we take to try it out? What images do you think, guys? We need some hard ones to evaluate the performance difference on GPT-4 and this CogVLM. I mean, let's do one thing I've tried to do as well is this is actually for, I can't tell you what it is, but let's just say we have this. We have this. Let's just say we have something like this. Curious as well if it can do it. Okay, so let's do a new one. This is, I guess, like a little bit of a harder task, perhaps. Extract all the nutritional information in the image. Please provide the result in a nicely formatted table. And same thing here. No, what the hell? It should not use any. No. You cheater. You cheater. Do not use any code interpreter. Okay, 212, 257 calories. All right, let's see if it's as good. All right, so there we go. So this is actually correct, right? This is really good. Total fat 9.4, 14%, 6%, 1.1 gram, 0, 41, 400, 10, 40, 2.1, 8, 10, 16, 3, 14, nutrition grade A base. So it's extracting everything. Here, nutrition serving size 212, calories, total fat, saturated fat. Okay, so all of these numbers are correct. It's just missing a few. This is also seriously impressive. I feel like open source is honestly catching up to GPT-4, which is exciting. And this is not a huge parameter model, right? It's huge, but compared to GPT-4, maybe it's not so huge. I think you need to clear ChatGPT context. Where's the context? Or what do you mean clear ChatGPT context? Like to, or to not use the code interpreter, you mean, or something? You are missing calories from fat, and also dietary fiber, sugars. I guess that's it. That's incorrect. Okay. So, I mean, it's not as good as we can see here. Let's try it on another. This might be prompting based as well, right? And then also if you increase temperature here. In the table, please revise the table to also contain the daily value percentage for each. This is I mean, like, this is huge though that we are able to have this. What would the actual costs be, you think? Like, if we would, I mean, it's like, I guess, I mean, let's just say you would rent it, right? Um, then it would be like, let's say $2 an hour, $2.5 an hour. How many inference calls do you actually need to make before it's worth it in terms of API? I mean, how many can you make before it exceeds? So it's, let's say 512, it's open. So let's just say, I mean, that makes sense. So we can do, I mean, now we're only doing the actual image, right? But if we do 1,000, then we get to 2.5. So, I mean, assuming the inference speed is faster, right? Which it probably is. This one is, I mean, obviously it's going to be a lot cheaper, I feel like. And at a certain point, right, we're going to only be able to make this faster, so. Oh, but it's not correct. Please revise. You did not revise the table at all. Please add another column that specifies the daily percentage value for each. For example, total fat 9.4 gram, 14%. It seems to have the capability. I think it's honestly the language model that's maybe not as good or something. See, like, it's not doing the correct, it's not like answering my, yeah, I mean, it's, you need to be doing really good prompting. I feel like GPT-4 is more forgiving in the prompting, but it definitely seems to have the like capability aspect. Um, mm, um, let's see. You are a nutrition tagger. Task extract. Please provide. We capture the gram for each nutrition fact, as well as the daily value percentage. Yeah, all right, let's try that. Yeah, I think GPT, I mean, on this, the OCR is good. Like it's actually capturing the actual quantity, right? Oh, now it did it. Oh, okay, cool. So it's prompting. You have to be better at prompt engineering. I think that's actually it. So here it says calories 257, daily average 14, 6, 1.1. This is not correct. Is it? No, it's not correct. It says 6%. Total fat. This should be 14. So it's not as good, I guess. Let's try it again on this one. Yeah, so this one is better for sure here at least. I wonder if it's prompting though. So if we increase this, would it help or no? And could you do some smart Kappa 123? I think ChatGPT has something plus your prompt as the input prompt, which forces the model to follow your instructions. Well, that's actually true. Yeah, you're right. Probably that might actually be it. That might actually be it, right? So I mean, the capability seems to be there, but we need to. I mean, it's doing some stuff wrong, right? So please, let's do this. Follow the instruction. Follow the user instructions carefully and be helpful. Something like this, maybe. Extract all the nutritional value information. Please. Okay, let's do this again. I wonder if you can do like chaining. So if you ask it to then refine it in some way, is it able to do that? Yeah, it's true. Yeah, I did follow it a lot better at this point. Okay, so see now though it didn't do it that well. So wonder if this has to do with the top K as well. And wonder as well if it helps if we decrease this the most as we can. So let's see. Let's see. Generally for LLM inference, if we increase top K, do we get do we get higher precision or lower? I feel like lower should probably be better in this case, right? Because we actually have, like, we're not trying to follow from many different words, right, in the token space. We're actually trying to find the exact one. So there is one correct. So maybe even if you lower this more, would be better. Um, mm, mm, see if this helps anything. Mm. I am designed to provide information, answer questions, help with generate creative content, and more. My capabilities are based on processing. Okay, let's do GPT-4 prompt prefix. Mm, mm, okay, maybe this is like the exact one it has. I don't know. See, it's not doing the correct thing here though. Like it's sometimes doing the correct, right? It's not adding the additional columns, which is a problem, even though we said exactly what it should have. So, yeah. Yeah, like one thing that's good though is that it did actually capture it though, in terms of the gram and the, yeah, but it did that before as well, right? So, let's see. You are a multifaceted AI language model capable of understanding and generating. Uh, your purpose is to help with nutritional information tagging and to provide nutrition fact, the gram, uh, and they leave percentage value. Okay, cool. Please provide results in a nicely formatted table, uh, and try your best to ensure we obtain all the information that is captured in the image. Okay, let's see if this is helpful. Okay, there we go. I feel like if it fails at this point, right, it's pretty dumb. Or no? Like we're giving it very clear instructions. Uh, hey, it helped. Guys, it helped. It helped. Nice. Wait, what? Calories, man. I mean, like daily percentage value. Oh, it's. I mean, it's. Yeah. Based on your response, based on your response, do you would you like to revise your result? That could. Would you like to revise your? To do. Let's see. Okay. Uh, if you look at the image again, you will find a mistake you made. Please, let's see if you are able to catch it. I believe in you. Yes, let's correct. Wait, what? Total fat? The mistake is that. What the hell? It wasn't even wrong there. The rest is consistent. Oh, come on. Come on. You dumb bastard. Goddamn. Okay, so if we put it at 0.8, does I can't imagine this improves. Add the prefix again. With oh, but I mean, like it has the context, right? It's chat based, so it should have all the context. So it already has it, I guess. Yeah, I think it's just not seeing like the exact rows or something. It's not seeing that. Maybe if you prompted it again, like it does seem to have like really strong OCR capability, but probably for like very specific types of inputs in the structure, it would have. If you play around with the prompting here, I imagine you would be able to catch all of these. Yeah, I think the there seems to be the limitation here seems to be in the language model actually, rather than the vision aspect. The vision seems to be pretty strong, I would say. Let's see if we take another one and we do the let's just try the grounding one as well. This one should give us let's see. So this one should give us the actual position using this glip v2 or something. So let's see how it works. But this is actually a truly insanely good. Like imagine as well, right? It's this good out of the box when playing around with it, and so imagine what the improvements will be, and then also imagine what you can get if you fine tune this. So if we're able to, I mean, we are able to fine tune it. They even have like a script for it. So if we added like specific domain knowledge on exactly what we want to do, you know, we could train it to do a lot of different tasks, which is really like truly amazing what this can do. It's kind of mind blowing, to be honest. You will very soon have a general purpose model like GPT-4 Vision, right? That will outperform like pretty much all models. And then this is something that you can actually create very specific and very unique to your exact use case, right? So, I mean, pretty amazing. Um, Pretty damn amazing. I think I would, yeah, I think probably as well, right? Uh, the only thing I see as the negative here is the actual language model. So the language model here is 7 billion parameters and it's not the best. So probably if we, what is the actual like best language model? Is it Mistral or something? Uh, but yeah, like when that catches up, man, I really want to build one of these from scratch, like this CogVLM. That would actually be insanely interesting. And then I'm wondering too, how do we, so you're able to chat with it as well, right? But if you don't input the chat, it doesn't seem to be, hello, if I can just do this, like it gives, oh yeah, we didn't actually try that, but we should be able to chat with it without the actual image, right? But it does the improvements downgrade if it actually doesn't have an image? So is it because it's trained having an image at all times, right? So what happens if you don't give it an image? Um, because I'm thinking like this is more of a general purpose model than just if you have the LM, and you would want to train this to sort of have it, but still have it as good as if it was only a language model. Okay, let's see. So someone said on LinkedIn as well. We should probably try that, right? It's uh full length doc PDR. Curious what max length output is and if it can handle full. I think output tokens is 2K. Um, mm, so what is input? So what is the like if in this scenario like did you try full length doc PDF OCR? So what would we actually do here? We would first of all let's just do this. So let's do 0.01 here. Can you provide a description and include the coordinates? A man. Yeah. Clothes. Okay, I mean this is good, right? Pretty good. But I feel like, hmm, I just feel like it's strange to me that it is able to do this because it seems to me like a much more complicated task to do this. Like, I wonder how it compares to actual object detector models in terms of performance, right? If you would actually use this as output. Uh, I don't know if anybody knows, then then do mention it. But so could we do like an let's see, could we do let's take a harder one. What's like a difficult object detector task? So imagine I'm trying to create one on Discord or Midjourney. So a penguin walking the streets of New York. I just want to like doesn't have seen actually seen this before. Okay, copy link. Okay, so I want to do this. Save image, and then let's go back. Let's put this in here. what was the can um detect all the humans in the image. Let's think step by step. What the hell? Wait, what? What? Find the human it exists. I don't know. I kind of like this one, to be honest. It has some type of uh figures in clouds. What do you mean exactly? Like this thing, the PDF OCR, or I mean, like, would he want to get? I don't know exactly what he's. I mean, did you take an image of of it, or is that what he wants? Like, you take an image of the PDF and then you input it. Can't you actually just read content from a PDF directly? Why would you want to do? Why would you want to do it that way? It feels very complicated. Uh, okay, let's do mention on. You think so? We can try it. I mean, we can compare it, right? I feel like it should be able to do. Yeah, so it able. Yeah, okay, but this is cool though. I mean, it's actually able to predict the penguin pretty perfectly here. I still think this is impressive. I'll be honest. I still think it's really insanely impressive. I think the prompting you probably does has a big impact. I would actually like to know the like actual detection of it. Is any of these actual detection things though? I don't know. Oh. Any of these machine learning metrics used in object detection. Oh, what is it called? Like, I guess not. It's not a. What is it called? Like, it's not a machine learning. Um, did we have Coco here? Coco caption. That's not detection, is it? Ref Coco? Ref Coco. Used for task visual grounding, which is closely related. The task is to locate. Okay. Yeah, I'm curious like how it actually compares, but I mean it does seem to have some really impressive performance. So yeah, all right guys. I think that's it for this stream. Uh was interesting for sure. Very interesting to see where this goes and what we can do with this. thanks for joining the stream. And yeah, does anyone have like any other types of questions or anything before I leave? Oh yeah, we didn't try it for baklava, by the way, but this is the MVP, so we should definitely try this as well. Baklava. I mean, I feel like it didn't seem to have good performance, but with this name, you kind of want to use it all the time. So yeah, I don't know what the delay is on the stream, so I just want to wait a little bit before I uh, stop the stream. All right, guys. Just trying to think as well. Is there anything else we would want to try with this? I would like to also try. I would like to really try like fine tuning this. To be honest, I mean we could run 4 A100s and try to fine tune it. That would be pretty cool. But I don't know what would we want to do. Like what would we want to fine tune it on? I feel like here I'm trying to think like what can we. I feel like there's so many things you can do with this, right? But the biggest thing seems to be that it is general purpose. So perhaps we will have some type of convergence of all of these. We've already seen like the architecture, right? So everything now is transformer based, and we are now also seeing a convergence of the actual model itself, or the yeah. So we are starting to see that more and more. You could use GPT-4 vision for anything, pretty much, right? Or most tasks, and then ideally you would be able to fine tune it specifically on the thing that you want. So yeah. So how is it difficult to fine tune this? We need 4 A100s, um, which needs a different. We provide a fine tuning example of the capture images. So okay, we have different styles, something, we have some type of OCR thing. We start the fine tuning with this command, fine tune LoRa. Okay, fine tune LoRa. Script, fine tune. Fine tune model type. And deep speed fine tune demo. So it's running some fine tune demo. It's running this thing. Data collator, get batch, beam search, temperature, top K 0. Okay. Maybe we can do that actually. Yeah, that would be really interesting. All right, anyways, guys, thanks so much for joining the stream. I'll stop this now. And yeah, let me know if you have any ideas as well on what we can do in future streams and ideas on that. I really want to try to get better at that and get back to making a little bit more. Anyways, this was cool. This was fun and really interesting. All right, see you.